Good morning to you all. Welcome into today's video. The past two videos we have discussed a number of basic definitions. I hope you had time to go through them and make sure that you understand them. Today, the video is going to be quite interesting. It is also going to be very important. I labeled it as tips and tricks, and I'm putting for you in this video most of the techniques or the experimental techniques, the measurement techniques that you are most likely to encounter while you are solving the alternative to practical paper. So please bear with me. The video might be a little bit long, okay, but it is going to be very important and interesting. Okay, let us get going. You will very frequently encounter using a measurement instrument which has a scale similar to this one. For example, what I am showing here is a measuring, okay, a meter rule, okay, and most of the time you will encounter measuring a lens or whatsoever using the meter rule. So the most important recommendation while you are taking a measurement on the meter rule, okay, is how to align your eye. Okay, how should I observe the measurement on the meter rule? The recommendation is always that you should observe the reading, okay, with your eye perpendicular to the scale. Okay, this is the recommendation that you should always make sure to observe the measurement with your eye perpendicular to the scale or the point where you are reading. Never align your eye with an angle for the measurement. Okay, if you do that, if you observe a reading in this with an angle, it is called parallax error. Okay, so if you are observing any kind of scale similar to a meter ruler or something like this, always observe it perpendicular. Why should we do that? To avoid parallax error. Okay, so this is how you should observe a scale. Okay. Another frequently asked question or exercise that you will encounter during your exam is if you were asked to calculate the diameter of a ball, a sphere, or a measuring cylinder, the measuring of the diameter of a sphere, ball, or a cylinder using a meter rule. Okay, if you try, you can try to imagine this. If you try to set your ball or sphere like this on the meter rule, okay, and you try to measure those 2 points, okay, here and here, you will find it a little bit difficult to allocate or locate where should you read it with your bare eyes. Okay, you will always find it difficult to take an exact reading on the meter ruler like this. Okay, then what should I do? We need to use two set squares. Okay, I'm going to use two set squares. This is 1 and this is 2, as shown in the figure. What I'm going to do, I'm going to squeeze the ball, okay, between the two set squares. I'm going to squeeze the ball between the two set squares, okay, and then try to measure the diameter of the sphere or the cylinder. What I'm going to do is, with the help of the parallel sides of the set squares, okay, I'm going to take a good measurement on the meter rule. Okay, then we use two set square and set the ball between them as shown in the figure. Using the perpendicular sides of the set square, we take exact readings on the meter rule. Okay, like this. For example, we have 5 centimeter, 5.5, okay, 5.6, 5.7, 5.8. It is kind of 5.9 centimeter on this side. On that side, we can say that it is 8.9 centimeter. Therefore, the diameter, sorry, is 8.9 centimeter minus 5.9 centimeter is equal to 3 centimeters. Okay, so whenever you encounter measuring a ball, the diameter of the ball, the diameter of the of a cylinder, whatsoever, something like this or a similar shape, and using a meter ruler, how you are going to answer this question, always mention that you are going to use two set squares, okay, to help or to guide taking an exact measurement on the meter ruler. And please make a small sketch of similar to this one, okay. Then we can say this is the meter rule. Here is the ball, here is the set squares, okay. You can show a similar diagram and then say that use the perpendicular sides of the set square to take accurate measurements on the meter ruler. Then the difference is the diameter of the sphere or the circular shape or the ball whatsoever. Okay, so this is a very frequent question that we usually encounter or we usually see in the exam. Okay, let us proceed. Another setup that we usually encounter is if you are asked to use a meter ruler to measure the length, for example, of a string. You are asked to measure the length of a string or the extension caused by weight on a string, something like this. Or you are asked to measure the length of a wire of the length of a uh, simple pendulum, or a something similar like this setup. So how you are going to answer this question? This is what we are going to do. One, use a meter rule, making sure it is perfectly parallel to the spring. You can use a stand with a clamp to help achieve this. Two, use a set square to help get an accurate reading on the meter rule. Three, align your, let me write it well. Align your eye perpendicular to the meter rule to avoid parallax error. Okay, then this is how you answer this kind of question or the similar. And it is always helpful if you can make a diagram. If there is already a diagram, then you can use it to add a meter ruler or whatsoever. I mean, as the question might require. If there is nothing like this, then you can just add a drawing. For example, here. This is the spring. Okay, we got another clamp. I just need to make sure and do the drawing with a meter rule so you get the lines more accurate. Okay, then I then use a set square like this, and I set my eye like this. Okay, and then write what I have mentioned before. Okay. Again, a recurring theme of questions that you might actually encounter in the exam is using a meter ruler and a couple of weights and a pivot, and you are asked, or the experiment states goes as that the meter ruler with the weights are being balanced on the pivot, something like this. Okay, and you are kind of asked how you can accurately set the mass, for example, the mass P on the meter ruler at an exact distance of 10 centimeter from the 0 mark. Okay, this is the question. How does it go? Set the weight, the mass P at exactly 10 centimeter from the 0 mark of the meter rule. Okay, then he's telling you that well, if you take a look at the meter rule, the setup, how we are going to put the mass on the meter ruler, then you could see that you cannot actually see the 10 centimeter. We can't see the 10 centimeter mark. Okay, and it is difficult to exactly set the mass at the 10 centimeter mark. So how can we do that? How can we answer this question? Okay, this is how you can answer this question. What we are going to say or do, A and B. Use the two perpendicular sides of the mass P, A and B, and make sure that their reading is A plus B divide 2 is equal to 10 centimeter. Okay, what does that mean? That means that, well, set the reading of this side as A, that side B, such that A plus B divide 2 is equal the number or the mark we were asked to set. In this case, it is 10 centimeter. Okay, then what we see over here, let us take the measurement on this meter ruler to see or to check if the center of this box is exactly at the 10 centimeter mark or not. Okay, we come from this side. It is 1, sorry, 2, 3, 4, 5. So A is equal to 6 centimeter. What about B? Well, I cannot see it from this side. I'm going to take the measurement on from that side. So we have 20, 19, 18, 17, 16, 15, and B is equal to 14 centimeter. Therefore, A is equal 6 centimeter. B is equal 14 centimeter. Therefore, A plus B over 2 is equal 6 plus 14 divide 2 is equal to 20 divide 2 is equal to 10 centimeter. Okay, therefore the center of the box is at exactly 10 centimeter. All similar. Okay, so this is kind of the technique. if you are asked to how you are going to set the weight, okay, at an exact mark on the meter ruler, what you are going to answer, or how you are going to answer, is that to use the two parallel sides, that perpendicular side and that perpendicular side, label them A and B, and state that A plus B divide 2 should be equal to 10 centimeter, or whatever he did ask you about. Okay, let us proceed further. Another question, not very frequent, but I have seen it a couple of times, and it's asking if we can measure the diameter or the radius, the radius, the diameter, the circumference of a cylinder using a string and a meter ruler. So the question is, using a string and a meter rule, find the circumference of the cylinder. So how do we answer that? We say that we are going to wind the string a number of times around the circumference of the cylinder. One, wind the string a number of times. For example, 5 times. Okay, wind the string a number of times, for example, around the circumference of the string and the cylinder. 2, stretch the string and measure its length using a meter rule. Okay. 3, divide the length of the string by 5. If we used 5, if we wind it 5 times, if we wind it 10 times, then divide the length by 10. If we wind it 15 times, then divide the length by 15. Okay, and you can, to complement your result, say it is always better to use a large number of turns or a large number of winds, not less than 5. Okay, so this is how you can answer such kind of question, using a string to measure the diameter, the circumference, the whatsoever. I mean, for sure you know the relation between the circumference, the diameter, the radius, and so on. Okay, just a reminder, circumference is equal to 2 pi r, which is radius. Circumference, it is pi d diameter. And this setup using winding the string, we measure the circumference come France. Okay. This is always, I always see it in every exam I have came across. I have always seen taking a measurement on a voltmeter and an ammeter. So how do we do that? Okay, it is quite simple. Okay, first of all, we need to find what is the smallest scale mark is equal. We need to check how much each small mark is equal. So how do we do that? Okay, we check the start and the first value on it is right. Okay, then we have 0 and 1. So from here to here we have 1 volt. Okay, and in between them we have 10 divisions. Therefore 1 division is equal to 0.1, or 1 division is equal 1 volt divided by 10 divisions is equal to 0.1 volt. Okay, so each small mark is actually 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, so on and so forth. So what is the reading over here? Till here it is 1.5, 1.6, 1.7, 1.8, 1.9 volts. So the reading here is 1.9 volts. Okay, that was simple and easy. Very similar, you will also encounter taking the measurement on the scale of an ammeter. So it is quite similar. The first thing we need to do, find what is the smallest scale equal. How do we do it? We see 2 marks, labeled marks, okay, on the scale. So we have starting 0 and 0.2. So this is 0.2. How many divisions do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. Okay, then we divide by 10. So 0.02 amps. So each small division is 0.02 amp. Okay, so till here it is 0.4 amp, 0.42, 0.46, 44, 0.46. The other one is 0.48, so 0.46 and 0.48. Okay, we have it between 0.46 amps and 0.48 amps. So any value between those two values is okay. Any value between those two values is fine. Okay, but looking at the scale, we could see it. Okay, we could see that it is almost halfway between 0.46 and 0.48. So a good estimate for the pointer reading is 0.47 amps. So the reading of this ammeter can be a 0.47 amp. And this should be okay. Okay, so this is how we do it. We calculate how much a small scale is. How do we do that? We see 2 marked scale points, the difference between them 0.2, then the difference is 0.2, How many divisions? We have 10 divisions. Then 0.2 divide 10 is equal 0.02 amp. And then we do the counting. Very simple, okay, and straightforward. Nothing. If it comes between two lines, okay, then always a good estimate that we can give it between. For example, this is 0.6, 0.62, 0.63, 64, 66, 68, and this is 70, 0.68, and this is 0.70. Okay, so a good estimate for this measurement is 0.69 amps. So on and so forth. Okay. This part is how to, you might be asked how to connect an ammeter and how you can connect a voltmeter. So always ammeters are always an ammeter is always connected in series to measure the current through a component. Okay, just to complement your answer, not, it is not actually to complement your answer. If you are asked, okay, an ideal ammeter must have zero resistance. This is for the ammeter. What about the voltmeter? How do we connect the voltmeter? Voltmeter are always connected in parallel with the component. So if you are asked to calculate the voltage across the component L, we are asked to calculate voltage across L. Then we have to connect the ammeter this way, parallel. A voltmeter must always be connected in parallel with the component. Okay, always need to be connected in parallel with the component. An ideal voltmeter has infinite resistance to reduce measurement errors. Okay. Okay. You might also encounter during the exam, you are asked to calculate, to give a reading for the height of a liquid inside a cylinder or a measuring tube. Or sometimes you are asked to give the reading of temperature using a mercury thermometer, and you have to measure the height of the thermometer inside the you have to measure the height of the mercury inside the thermometer. So if you remember or recall from your class, okay, when we have water inside a measuring tube or a cylinder, okay, the surface of the water will never be flat. We're not going to see a flat surface in the water, but what we are actually going to see, that we are going to see such a shape, okay, a curved surface for the water, and this is called meniscus. This shape of the liquid surface inside a measuring cylinder or a tube is called the meniscus. And there are actually two types of meniscus. Okay, one of them, it is concave, and how does it look? It is bent or curved inside. It is curved to the inside. Okay, we also have convex meniscus, and for the convex meniscus, it is curved on the outside. The curvature does look like that. Okay, it always, the convex meniscus, I have only seen it in mercury. Okay, all other liquids, typically the meniscus is similar to that of water. It looks like this. Okay, so this is how the meniscus. So how are we going to read this scale? How we are going to read the scale? Should we read it from here, from this level, or should we read it from that level? So the correct way to read the lens volume of a liquid in a beaker or a measuring cylinder is using the meniscus. Okay, so we don't read it from here. We read it from the level of the meniscus. We don't read it from here. No, we read it from the level of the meniscus. Why do we do that? You might be asked to, why do we always read it from the meniscus? To reduce measurement error, or to reduce reading error. Okay, so if you are giving a volume or a water level inside a measuring cylinder, and you are asked to find the volume, okay, or the height, whatsoever the reading is, okay, never take a reading from this side. Wrong, right, right, wrong. And make sure to state that we should keep our eye perpendicular to the scale to avoid parallax errors. Okay. So let us do this exercise over here. Okay, so we have in this question, you are asked to find the volume of an irregular shape, like this one. We would like to find the volume of this irregular shape. If the shape is regular, we can find its dimensions and then calculate the volume. If irregular, we need to use the water immersion technique or method. Okay, how we are going to do that? One, use a known volume of water. Okay, so we fill the cylinder with a known volume of water. Okay, like this one. This is step number one. So what is the volume over here? It's 140. We have 150. It's 140, 150. How many scale divisions between them? 1, 2, 3, 4, 5. So each small one scale division equal 10 divide 5 is equal to 2 centimeter cube. Okay, so what is the reading over here? It is 140, 142, 144. Okay, and notice the meniscus. Notice what? Notice the meniscus. Can you see? Okay, can you see it? Okay, the small level over here. So as we said, we are going always to read it from the meniscus. This is the one. Okay, is in 140, 142, 144 centimeter cube. Then to fully immerse the object in water. Okay, like this one. Make sure it is fully immersed in water. Take the reading. It is 150, 152, 152 centimeter cube. Therefore, the volume of the object is 152 centimeter cube minus 144 centimeter cube is equal 8 centimeter cube. So this is how we find the volume of an irregular shape using a measuring cylinder and water. If you are asked to use a thermometer to take measurement of temperature of a liquid or anything else, okay, the way to answer this question is one, use a stand and a clamp to make sure that the thermometer is vertically upright. So we need to make sure that the thermometer is always vertically upright. We don't use the thermometer while it is like this or like this. Always make sure the thermometer is vertically upright. Okay, to align your eye perpendicular to the scale to avoid parallax error. Okay, to avoid parallax error. So what is the scale? It is, here is 20 degree centigrade, here is 30 degree centigrade. How many divisions? 10 divisions. Therefore, one scale mark equal 10 divide 10 is equal 1 degree centigrade. Okay, so the measurement over here, it is 21, 22, 23. So it is 23 degree centigrade. Okay, very simple. An easy thing that you encounter in some of the exams, you are asked to find the mass or the weight of a sample, okay, a block of metal or whatsoever. Okay, so typically you will be giving a digital balance, okay, to do the measurement. This is how a digital scale looks like. Just for comparison, this is a beam balance. I have never seen it being used in any exam. Most of the time, the question is about using digital balance. And how you take the measurement or the reading is directly from the scale. Directly from the scale. So the mass of the object here is 0.0436 kilograms. The one over here, it is 50.78 grams. Okay, very simple and straightforward. But what if I'm asked to find the mass of a liquid? Sure, I cannot put the liquid directly on the scale, okay? It will just spill, right? So what I need to use is a measuring cylinder. I need to use a measuring cylinder. Actually, it must not be a liquid. It could be a powder, okay? You cannot put a powder on the measuring, on the balance and take the reading. You have to use a tray, you have to use a dish, whatsoever, okay? Or for a liquid, you have to use a beaker or a measuring cylinder as available, okay? So, but how do we do that? So first of all, okay, or let us say there are two methods. I'm going to show you the two methods. The first method is measure the mass of the empty cylinder container. What should I do next? I fill the cylinder with the mass of water I would like to measure, the volume of water I would like to find it is mass, the powder I would like to find it is mass. So I fill, add water, liquid to the measuring cylinder and read the mass of the cylinder plus liquid. Okay, like this one. So the empty cylinder was 50 grams. Cylinder plus water is equal 70 grams. mass of water only, or liquid only, or powder only, is 70 minus 50 is equal to 20 grams. Okay, then it is directly and straightforward. You take the difference and you get the mass. So the other method, it is just a variation of this method. Again, we set the cylinder on the scale, or the empty cylinder on the scale, but we don't take a measurement. There is a button on the scale or the digital balance. It is called tare. Okay, use the tare button to set the scale reading to 0 with the cylinder on. Okay, so I put the empty cylinder, it reads a value, for example 50 grams, then I push this button and directly I would see a measurement of 0 grams on the scale. Now I see 0 a reading of 0 grams on the scale while the beaker or the cylinder is still on. What should I do next is now put the volume of water you are interested in the measuring cylinder, and directly are going to find the reading, or the scale this time is going to give you the exact volume or the mass of the liquid or powder or whatsoever. So the first method, you just take the mass of the empty cylinder, then you take the reading of the mass of the cylinder plus water, subtract, and you get the mass of water. Okay. In method 2, okay, we use the function tare bottom on the digital balance. Okay, we take a we don't take a reading for the empty, we just put the cylinder on the scale, we use the tare bottom. Okay, it zeroes the scale. Okay, then we add the water to the cylinder and we directly take the measurement. Most of the time, so let me tell you, most of the time you will be using method 1. Most of the time. If you are asked to explain how to take the measurement of the mass of a liquid or a powder or whatsoever, please describe method number 1. I'm just complementing your understanding. In the case that he is asking you to use the tare button, okay, or he mentions the tare button or the 0 button in the digital scale, then you know how to use it. But in the exam, please, in your exam, if asked to find the mass of a liquid or powder, please use method 1. Unless he explicitly tells you to use the tare bottom on the scale. Okay, I think this is all for today. This is going to be a very important video. Okay, if you understand it well, it is going to make solving the exam paper easy and straightforward. So make sure to go through it as much as you need. I hope it was entertaining and useful for you, and see you next time. Thank you.